All right, let's go ahead and get started. I want to welcome you back to the second screencast for Unit 4, the periodic table. So in our first look at the periodic table, we discovered a number of things, the first one of which was just the basic anatomy of the periodic table. We see that this first column, this one right here, are known as the alkali metals. The second column was called the alkaline earth metals. And we said that this block of these first two columns was the S block. So this block right here was the S block. And the reason we call it the S block is because of the fact that elements that are in this block, elements that find themselves in these first two columns, whether they be hydrogen or lithium or magnesium or rubidium or whatever the case may be, have their last electron in an S sublevel. So let's look at an example. Let's take, for example, magnesium. I want to write the electron configuration for magnesium. Now we know that magnesium has 12 electrons in it. And so now from the periodic table and our understanding of the periodic table, we know that there's a relationship between the electron configuration and the position on the periodic table. So what we're going to do is we're going to read as though we were reading a book. We're going to go left to right, top to bottom. So remember, for hydrogen, I'm going to start with the first main energy level because that's on the first row. So I'm going to say 1. We're in the S block, so I'm going to say S. And remember that I said in the last video that helium was also in the S block, even though it was positioned here. So we're going to say 1s2. So that takes care of the first 2 of the 12 electrons of magnesium. So 1s2. Then we'll come back down. So we've taken care of that first row. We'll come back down as though we were reading a book. And we're in the second main energy level now. So we're going to say 2s. And to go to beryllium, we'll take 2 electrons just like that. So 2s2. Now we're going to jump across to the P block. We said that this block here was the P block. And we're at boron now. And we're going to say boron to neon is 2p6, just like that. So that takes us to neon. We're almost there. We're in the third main energy level now, 3s2, just like that. So that's it. That's the electron configuration for magnesium based on the periodic table. So we don't need that mnemonic that we used when we were studying about the quantum atom anymore. We can get electron configurations directly off of the periodic table. Remember also that this block in the center here was the D block and that the D block was staggered. That meant that, for example, when you're in the fourth main energy level, to get into the D block, you're going to drop down 1 main energy level to 3. 5 goes to 4, 6 goes to 5, 7 goes to 6, just like that. All right? On the right-hand side, we had the P block, and on the bottom, we had the F block. All right? All right, so that's just in the way of review, and now let's move on to the more recent material. So here we go. Since elements in this block, that's the D block, are to the left of the zigzag line, which separates metals from nonmetals, they are called metals. So if we're in this area here of the periodic table, we're going to call these the transition metals. They're in the D block, right? The transition metals are on the D block, and they're to the left of the zigzag line that we talked about last time. That zigzag line goes something like this, and we'll talk more about it later. But the point is that because it's to the left of that zigzag line, these are metals, and we call them transition metals if they're in the D block. Transition metals if they're in the D block. Now the elements which touch the zigzag line are known as the semi-metals or the metalloids, and they have the properties of both metals and nonmetals. So if we go back up, we'll use this chart this time because it shows a little bit more clearly what the transition metals are. Anything along this zigzag line right here, anything along that line right there is called a semi-metal. It has the properties of both metals and nonmetals. Silicon, for example, is very important in the computer industry for the production of computer chips. It has properties of metals and nonmetals, right? So we call it a semi-metal or a metalloid. All right? So we're just getting some kind of a feel for what types of elements are positioned where on the periodic table. It says the elements to the right of the zigzag line are called the nonmetals. These include the elements in the second to the last column known as the halogens and the last column known as the noble gases. So if we look to the right of the zigzag line, if we look all the way to the right of the periodic table, we see everything here are nonmetals. Everything here is not going to be a conductor of heat and electricity, for example. We call this column right here, let me move up just a little, we may call these the halogens. So the second to the last column, fluorine, chlorine, bromine, iodine, and astatine are the halogens. And the last column we're going to call the noble gases. Helium, neon, argon, krypton, xenon, and radon are what we call the noble gases. So once again, nonmetals to the right of the zigzag line. The last two columns, the second to the last column, we call the halogens. That's fluorine, chlorine, bromine, iodine, and astatine. And the last column we call the noble gases: helium, neon, argon, krypton, xenon, and radon. Okay? All right. So that kind of completes the anatomy of the periodic table and helps us to understand where things are. Now, elements in the P block, that's that central or the right-hand block of the periodic table, have atoms whose last electrons are in a P sublevel. For example, let's take the element phosphorus, right? Phosphorus is in the P block, right? So phosphorus would be right here on the periodic table. Let's find phosphorus right. Let me erase this so we can see phosphorus a little bit better. Phosphorus is right here. Okay? So it's obviously on to the right of the zigzag line. It's a non-metal, right? And that means that it's not a good conductor of a heat or electricity, but more importantly, it's in the P block. What that means is that its electron configuration has the last electron in a P sublevel. Let's use the periodic table to determine the electron configuration for phosphorus. We're going to read like we're reading a book. 1s2, that takes us to helium. 2, we're in the second main energy level. 2s2, we're in the S block. 2p6, we're in the second main energy level, but the P block now. 3s2, third main energy level, S block. And now we get into the third main energy level, P block. 3s1, 3p1, 3p2, 3p3. So let's do the whole thing again. 1s2, 2s2, 2p6, 3s2, 3p3. That would be the electron configuration then for the nonmetal phosphorus, right? The nonmetal phosphorus. So what we've learned is that we can determine the electron configuration from the periodic table. That's something that Mendeleev and Moseley didn't dream of happening, right? But that is something that we can get from the periodic table. The block on the very bottom is known as the F block. The F block. Of course, it corresponds to the F sublevel in the electron configuration series. The first row of this block is known as the lanthanides, and the second row is known as the actinides. So just a little bit more in the way of the anatomy of the periodic table and where things are. So they fit, since they fit into the slot on the left side of the zigzag line, they are considered intertransition metals. So let me kind of show you what that looks like on the actual periodic table. So once again, this last block, these last two columns on the periodic table constitute the F block. So the F block is this down here, okay? The first row is known as the lanthanides. The first row is the lanthanides. The second row is the actinides. And these fit in a little, let me go up to this periodic table right here. They actually fit right here. See how it goes here from, we skip numbers here, right? So right here, right there, is where this block fits in. Of course, we don't put it there because of the fact that if we were to put it there, it would expand the whole bottom part of the periodic table, making it kind of unwieldy. But the lanthanides, the first column, and the actinides, the second column, really should fit into that slot right there, right? They don't, but obviously they're metals because they're to the left of the zigzag line, and that is the F block, right? That's the F block of the periodic table. All right, so that should do it then for understanding where things are on the periodic table. We want to finish up with one last idea, and that is the periodic law. What is the periodic law, and what does it mean to us? The periodic law states that the physical and chemical properties of elements are periodic functions of their atomic numbers. So what does that mean? In other words, when elements are placed in order of increasing atomic number, as Moseley did in the periodic table, certain elements of physical and chemical characteristics such as melting point, boiling point, and reactivity repeat themselves. So the periodic law says that if we look at the periodic table and we understand that the periodic table is arranged in order of increasing atomic number, right? So we're going to go from 1 to 2 to 3 to 4 and so forth, that elements' properties, the physical and chemical properties of elements repeat themselves. The periodic law says, for example, that all elements in this first column have similar physical and chemical characteristics. All elements in the second column similar physical and chemical characteristics, and so on, right? So, for example, let's go to, and let me erase this again so we can see just a little bit better. Let's go to silicon, for example. Silicon is right here on the periodic table, right? Let's just say, for example, that the world was running out of silicon and we wanted to continue to manufacture computer chips, but we need to find another element that has similar physical and chemical characteristics to silicon. What would we choose? What might we choose? Well, we might choose anything in this column right here. Carbon, germanium, tin, or lead. These are going to be most likely to have the same physical and chemical characteristics as silicon. Just as likely, if I had oxygen, for example, and I wanted to find an element similar in physical and chemical characteristics, I would choose something in this column right here, okay? So again, that is the periodic law. Once again, the periodic law says this, that when you arrange elements, as Moseley did, in order of increasing atomic number, then what's going to happen is that there will be periodic repetition of the physical and chemical properties of the elements. In other words, the melting point, for example, the boiling point, these are going to repeat themselves over and over and over again on the periodic table. Everything in the same column is going to have similar physical and chemical characteristics. And that's why we call it the periodic table. That'll do it for this screencast. I'll see you in the next one. Thanks. Bye-bye.